These first two. And what I want to do is remind you guys of little tips and tricks of what to do when you see certain things. In these first two examples, what are the coefficients on the x value? I'm sorry, the x squared value, excuse me.
4 and -1.
They're both 1. That value in front of the x squared for both of these is a 1, okay? We just don't put the 1 there because it just wastes time, it takes up space and ink and all that kind of fun stuff, all right? So that's why we don't bother with it. So as you get into this, what I want you to think of, you're still doing this. What's 1 times -4?
Oh,
-4. So I'm going to ask, what times what is -4 that I add together to get -3? What that means here in the column on the left, I list out my factors of 4. 1 times 4, 2 times 2. Some combination of those two numbers, with one of them being positive, one of them being negative, will give me -3 when I add them together. Obviously, it's not this one, so it has to be that one. And the reason that the 4 is negative is because since the 3 is negative, the bigger of the two numbers has to be the winner of the sign. That holds true whether it's positive or if it's negative, okay? The bigger of the two, whatever number is negative or positive, the bigger of the two has to be that. So that means that if I add these together, I get -3. So since my first term here has a 1 in front of it, I can just go ahead and write x plus 1, x minus 4, and set it equal to 0. Let me ask you this. Does it matter which of these go first, the x plus 1 or the x minus 4? Nope. That makes no difference whatsoever. There will be a trick that I'll show you about when you have a first term that's not 1, and I'll show you that trick in a second. So now, these are what we would call terms, okay? Terms, if I multiplied that out, would generate that x squared minus 3x minus 4 if I FOILed all of that out, okay? But I'm looking to find my zeros because it's set equal to 0. So you set both of these equal to 0. What plus 1 is 0? -1. What minus 4 is 0? 4. And that's how you factor. Okay? You go through a process. Now, I know that you guys grew up through the system of multiple algorithmic ways to do things. All right, I used a big word there. Algorithmic, that just means methods of solving problems. You guys did box methods, reverse lattice, you did all this other weird mumbo jumbo. I'm not gonna lie to you, that's all great. But if you come back to this method, the one that always is easier to set up, just fall back on that. Okay? It's a nice, clean method that you ask yourself the question of what times what multiplies to the ends, and it adds to the middle. If you do that every time, it's gonna be a little easier on your brain, all right? On the next one, again, I have x squared plus 19x plus 88. That means, in the back of my mind, I'm asking myself, what times what is 88? But you add it together and you get 19. Right. Yes, sir? Oh, what do you got? 11 and 8. Very good. And it's nice when you can recognize that you have an 88. That means off the top of your head right away, oh, that's a 1 times 8 gives me an 8. 1 times 8 is 8, so 11, 88. Now, could you list through and go through everything? 1 and 88, 2 and 44, 4 and 22,
Yeah, if you want
and
to.
then 8 and 11, and then you get to there. It's not that many. It seems like it could be, but it's not. Could you also kind of guess and check? Since everything here is positive, that means both terms then will be positive, good. So that means my answer would have been x plus 8, x plus 11, and generates zeros where? What are my two zeros then?
Negative.
Negative 8, good, and negative 11. Where does it cross the x-axis? Negative 8, negative 11. That's what those questions technically are asking you when you're factoring stuff out, okay? So even though that you're working in geometry, we're working with all this geometric terms with segments that are secants and tangents, and it generates algebra equations, which generate quadratic equations, which generate parabola style graphs. All of this math is all intertwined together because you have to use one part to solve another, okay? That's where all this stuff comes from. Okay. When you get to 67 then, or on one like this is where things change up a little bit.
Wait. I think I might have figured it out.
Well, hold on, Wesley, let's let everybody get a chance here, okay?
Come on, it's not fair.
It's okay.
It's not fair.
So when you get to one like this,
You think I haven't figured that out yet?
whiskey, enough.
Sorry.
What happens with a problem like this then is that you're still doing the exact same thing. Instead of being a 1x squared, it is now a 5x squared. What changes, instead of 1 times 6, it is 5 times 6. It's still multiplying the tails together. What's 5 times 6? 30. So you're going to ask, what times what is a positive 30, but you add it together and you get a negative 13. Now right away that should tell you one thing for certain. What's the sign of both of these numbers going to be? Negative, good. You have two things that multiply to get a positive, but two things that multiply or that add to be negatives. That means they both have to be negative. Okay. So listing out your 1 through your 30s. 1, 30. 2, 15. 3, 10, and 5, 6. It's not that many. After a while, you'll be like, oh, I know it's not going to be 1 and 30 or 2 and 15, but which one will it be?
3 and 10.
3 and 10. Yeah, it's got to be 3 and 10 because the signs, negative 3, so negative 3 and negative 10. Now, I can't just write out my two terms now. Since that first value here is not a 1, we have to turn this into 4 parts. And then we do what's called factor by grouping. We had a couple of these last night. Do you see how negative 13 has been split into minus 3, minus 10? Because isn't negative 13 the same thing as writing minus 3, minus 10? Put those together, you get negative 13. What we're doing here is it's called factor by grouping, or sometimes people call it split middle term. I think that's how I just call it. What's the point of it? Because now what you're doing is that since you have an even number of terms, you break it into 2 parts and you go for GCS. Okay? No, because you don't know what this breaks into. You have to figure out what your terms break out. Because that's the rule is that you still have to know what multiplies to the tails that adds to the middle. Okay. So if I'm looking at 5x squared and a 3x, what do they have in common? They just have an x in common. So I have 5x minus 3. Now, this is kind of the trickiest of them all of the styles that you might see. Do you notice how both middle terms are both negative? Generally what happens is, if I have a positive and a negative term in the middles there, I usually write the negative one first and the positive one second. That way I don't screw up anything with my signs. In this case, I have to be a little bit careful. Here's the way I always do it. Let me move this over just a bit. So this was minus a 10x plus a 6 Normally what I do is this. I do a plus minus and I regroup it. The reason that I do that is so that way I remember I need to factor out the negative. So if I look at a 10 and a 6, what do they have in common? They have a 2. But I want to take out this negative, so I bring out a negative 2. So what's negative 10 divided by negative 2? What's 6 divided by negative 2? Are these two now the same? Yeah. Once you get to that point, you get both those two being the same, what you do is write that down. What's left? X minus 2. That's why we do it that way. That's why we split these things out. Okay? So does that make a little bit why we're doing it like that from yesterday? When you split them out like that, you're able to take a trinomial that you can't just guess and check your way through. You split out that middle term and you refactor just by using GCFs, greatest common factors. Because you guys have all learned about greatest common factors long time ago. That was one of the first things you learned about. What's that? What do you mean distribute?
You don't have to do that?
No, because you're factoring it out. I'm taking everything, I'm breaking it into other parts. So now you have two things that are equal to 0. 5x minus 3 is 0. One of these is really easy. Which one is it? The right one. What's x in equal? Here you have to do two steps. You add 3, and you divide by 5. So you have two answers, 3/5 and 2. And that's perfectly fine that you can get fractional, what are called fractional zeros. It's no big deal. It's no big deal at all. It just means crossing the x-axis at 3/5 and at 2. Okay. Is that kind of unclouding it a bit? Hope so. Okay. Let's try another one. So we have 8x squared minus 6x minus 5 is 0. Thank you. I can read. When you multiply your tails together, what do you get? What is it? Negative 40, good. Multiply your tails, you get negative 40. So I'm gonna ask, what times what is negative 40, but it adds together and equals negative 6? Very good. So we know that's gonna be a negative 10 and a positive 4. Everybody can see that, or do I have to list out all my terms? Are you okay with that? Sometimes they're pretty quick, okay? So we know it's gonna be a negative 10 and a positive 4. So when I break this apart now, I'm gonna rewrite this as 8x squared minus the 10x plus 4x minus 5.
So he takes only 8. He takes just
This is what I was saying a second ago. If you have alternating signs when you split it out, put the negative one first. That way you don't have to worry about that whole negative in that secondary part. Okay. And you group it again. What does an 8x squared and a 10x have in common? A 2x. So I factor out a 2x. That's the GCF. 8x squared divided by 2x is 4x. Negative 10x divided by 2x is minus 5. What do those guys have in common? 1, good. If they have nothing in common, that means they always have in common 1. So if I factor out a 1, do I change anything that's in the parentheses? No. Are the two terms that are in parentheses the same?
Yes.
Yeah. Write it down. What's left? That means now you have two terms that are set, that you can set equal to 0 to figure out the zeros, figure out the solutions. 4x minus 5 is 0, and 2x plus 1 is 0. This one here, what do you do first? Add 5, then what? So this one gives you x is 5/4. And then what's the other one going to be? -1/2. Because you subtract 1, divide by 2, and you get that. Now, I don't want to scare you here at all, but this is, yes, it's too late, I know. This is stuff that we're kind of hoping you guys kind of remember, okay? Just to fair warn you on this, because, bless you, you will have to factor and do all that other fun, happy fun stuff here this week, okay? Let me give you some more 10-6 stuff to try and add some more of the factoring to it. I'm thinking that the easiest way to go about all of this, because of the amount of material that we have, we might just wait till Friday to test. I think that might be the easiest or the best bet for us. You guys feel lonely not getting the papers at the front anymore? So let's see, let's do. Yeah. Oh well.
He gave us way too
Yeah, there's no room to do all the work on this paper. Just use this as the example, as the problems themselves, and then just do all the work on a separate sheet of paper, okay? Because there is no way, and I do not want to see anybody try to write this on this sheet of paper. You will not have room. But that way, because the first three are just kind of go straight through. The back half has a lot of the factoring into it, okay? So it's a lot of practice on the factoring. So utilize what we went over again today and what we did again yesterday, trying to help yourselves through it. It does not go away, so you guys know. All right? Thanks, sir.